All right, so arithmetic series. An arithmetic sequence was when the pattern was we are adding or subtracting the same number over and over again. An arithmetic series is when we are adding up all of the terms of an arithmetic sequence. Okay? So instead of just listing the numbers, we want to know what the sum is of all those numbers at the end. Okay? We start with an example. I want you to, without a calculator, here's an example of a series. Okay, without a calculator, find the sum of these numbers. That's what a series is. Without a calculator, find the sum of these numbers. All right, what do we get when we add up 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7? 55. Okay, we should get 55. How many people just added 1 plus 2 is 3, plus 3 is 6? Raise your hand if that's what you did. Okay, a lot of you. Did anybody do anything different? Anybody have a different strategy?
Well, I didn't get the right answer, but I did 9 plus 1 first.
Okay.
20 with the other 10.
She did 9 plus 1.
And I got 28.
And then 10, and then started adding the other numbers?
Yeah.
Okay. Brody?
1 and 9, 2 and 8, 3 and 7, just like because they're pairs, they equal.
Okay, so we did 1 and 9, 2 and 8, 3 and 7, 4 and 6. So that's 10 and 10 and 10 and 10, and then 15 at the end. Okay? Right? 10 pairs, that's how I add up golf scores. I usually have lots of 6s and 7s to put together. Anybody else do something different? Jonathan?
Started from 10 and then added each one going down.
Okay, so you went 10 plus 9 plus 8 plus 7. Anybody else have a different strategy?
I did 1 plus 2 and then 8 plus 4. And then
Okay, so you did 2 at a time and added those up. Anything else? Those are all the strategies you used? So my strategy is to add 1 and 10, and I get 11. And then 2 plus 9 gives me 11. And 3 plus 8 gives me, and 4 and 7, and 5 and 6 gives me 11. And there's how many 11s? 5 times 11 gives me 55. Okay. This is where our formula comes from. Okay. There are how many numbers from 1 to 10? 10, right? And if I divide that in 2, I got 5 pairs, correct? And my 5 pairs added to 11. That's where our sum formula comes from. The sum of any number of terms is the number of terms divided by 2, because you're going to pair up the first and the last term, and then all the numbers below that as you pair them are going to add to the same thing. Like you saw here, it was 11, 11, 11, 11. Because you're pairing them, you have half the number of terms. So that's our formula. N over 2 times A1 plus AN. So we're going to find the sum given several different pieces of information. If we don't know something for this formula, we might need to use yesterday's formula to find what we need. Okay, so I'm going to write down yesterday's formula again. The more you write it down, the more it becomes committed to memory. A1 equals A1, or AN equals A1 plus N minus 1 times D. So for number 1, remember, I'm doing the first problem, you're watching, and then you're going to do the second problem. Okay? So you're watching and listening and paying attention to what I'm doing, and then you're applying that to the second problem. Okay? So it tells me that A1 is 3, N is 12, and AN is 36. So I'm going to plug it into my formula. S of 12. That means I'm adding up 12 terms is equal to 12n divided by 2 times a1. What does it tell me a1 is? 3 plus an, 36. So that's 6 times 39. And now I need a calculator. Okay. 240 minus 6, 234, yeah? I'm still going to verify, given the mistake I made yesterday. Okay, 234 is the sum of the 12 terms. Because what we don't want to do is write them all out and then add them all up, right? That's a lot of work. So the formula allows us to quickly find the sum. All right, now try the second problem. A1 is negative 4. That's a negative. N equals 20, and an equals 91. You should have got 870. Plug it in. S of what? What's my little subscript going to be? 20. Okay, that's notation. It's just telling the sum of these 20 terms is 20 divided by 2 times negative 4 plus 91. That's 10 times 87, which is 870. All right, number 2, example 2. Find the sum given that A1 is 5, D is 4, and N is 11. So if I start with my sum formula, S of 11 equals 11 over 2 times 5 plus AN. What am I missing? AN. Do I have other information that could help me use the other formula to find AN? Yes, right? I actually need A11. So A11, the 11th term, which will be the last one I'm adding up, is equal to A1, 5, plus N minus 1 times D. Using the formula from yesterday, we can find the last term. 5 plus 10 times 4, 5 plus 40, A11 is 45. Now that I know what the last term is, I can plug it in and finish finding the sum. Okay. So that's 5.5. 11 over 2 is 5.5. And 5 plus 45, 5.5 times 50 is the sum of the 11 terms, 275. So sometimes you've got to use the other formula to find something you need in the sum formula. What I like to do is plug in what I know, and then that helps me figure out what I need to find in the other formula. Okay, so now let's try your problem. A1 is negative 121. D is 3, and N is 8. Okay, so we should have gotten negative 884. When I plug in what I know, S of 8 equals N over 2, so 8 divided by 2, negative 121 plus A8. Or AN, it doesn't matter how you write it, but really I'm looking for the 8th term so that I can find the sum of the 8 terms. So I'm going to plug in A8 equals negative 121 plus N minus 1, that's 8 minus 1 times 3. So that's negative 121 plus 7 times 3, which is negative 121 plus 21. So A8 is 100. Then I'm going to plug that back into my sum formula. 8 over 2 is 4. Negative 121 plus negative 100. Oh, that's a negative 100. And that's 4 times negative 221, which is negative 884. So the sum of those 8 terms is negative 884. It's okay if they're negative because you're adding up negative numbers, right? If the sequence starts at negative 121 and it's going up by 3, right, it's going to negative 118, then it's going to negative 115, then it's going to a negative 112. You're adding up a bunch of negative numbers. So it's okay if our sum is negative. Right? Yeah.
Can any sum be negative?
Can any sum be negative?
Can n be negative?
N cannot be negative. Yeah, you can't have a number of terms that is negative. So n should always be positive. Okay. And n has to be a whole number. You can't have a half of a term. Okay, so find the sum Sn given that the sequence or the series is an or 89 plus 86 plus 83 plus 80. What information do I know from my series? D is negative 3. What else do I know? A1 is 89. And what would 20 be? AN, right? What do I not know? N. I don't know N. If I plug stuff into my formula, Sn equals N over 2 times 81 plus 20, 89 plus 20. I don't know N. Right? Can I use my formula from yesterday to find n? Yeah, plug in what you know. An is 20 equals A1, which is 89, plus n minus 1 times negative 3. Remember that formula, A1 plus n minus 1 times d. So 20 equals 89 plus minus 3n plus 3. 20 equals 92 minus 3n. 20 minus 92 is negative 72. Divided by negative 3. So n is equal to what? 72 divided by 3 is 24, right? You're going to be asked to use these two equations in lots of different ways. Find n, find A1, find the d. Now I can come back to my sum formula and S of 24, because now I know what n is. 24 divided by 2 plus 109, 89 plus 20. So that's 12 times 109. S24 is equal to 1,308. Questions? So now try your problem. 13, 16, 19, 21, ending at 46. Okay, so there's a little mistake. There should be a 2, so that should be 22. Then it continues to be arithmetic. What information do I know? D equals 3. A1 is 13. and an is 46. So for my sum formula, n over 2, 13 plus 46, a1 plus an, what do I need to know to finish this problem? I need an n, right? So I'm going to use my an formula, a1 plus n minus 1 times d, and I will find the how many terms there are. Oops, what's an? In this case, it's 46. So that's 46 equals 13 plus 3n minus 3. 13 minus 3 is 10 plus 3n. And 36 equals 3n. And n equals 12. Yes? And then I plug that back in for my n, 12 over 2. 13 plus 46 is 59. So 6 times 59, S of 12 equals, just get my calculator out here, 354. Is that what we got? All right. Okay. Are you guys ready to learn about the real sigma? Actually, the real sigma. Okay. Sigma is a mathematical notation. It is an uppercase Greek letter that represents the sum. So since a series is finding a sum, sigma is used to shorten the notation. It is used in statistics, in calculus, and in algebra 2. Lowercase sigma is used to represent standard deviation. Okay, it's like the circle with the hat on it. It gets used a lot in statistics more than anything else. So when we are looking at sigma notation, we have to recognize that that is telling us to find a sum. When we are evaluating sigma notation, we are finding a sum. Okay? It always has a number on the bottom. The letter, the variable can change, but it represents the first term, the first value we're going to plug into I, and then the top represents the last value that we will use for the variable. The equation here is the formula for the terms. It's the rule. So what does this mean? The series described by this sigma notation. It means I'm going to start with the number 1, and I'm going to plug in every number from 1 to 10 to my equation, find those values, and add them all up. So by hand, evaluating sigma notation by hand looks like 3 times 1 plus 3 times 2 plus 3 times 3 plus 3 times 4 plus 3 times 5, 6, 7, 8, 3 times 9, and 3 times 10. That's what sigma notation is representing, and we're adding those all up. So that's 3 plus 6 plus 9 plus 12 plus 15 plus 18 plus 21 plus 24 plus 27 plus 30, and that's all 10 numbers. And that sum equals what? Go ahead, use your calculator and add that up. Did you get 165? You probably added an extra plus sign somewhere. Right. Now, we didn't just learn a sum formula for no reason. we can use the sigma notation and our sum formula to shorten the process, especially when there's 10 numbers. Okay, if there's 4, doing it by hand is easy. If it's arithmetic, we can use this formula. If it's not, if it has like an x squared in it, you have to evaluate it by hand. Okay, and we'll talk about other types of special sequences in series later. So what does it mean using our sum formula? Okay. How many numbers were there from 1 to 10? 10, right? So S of 10. We said n was 10 divided by 2 times the first term, A1, which is 3 times 1, plus the last term, which is 3 times 10. That ends up being 5 times 3 plus 30, which is 5 times 33, which is also 165. Okay, so let's evaluate some other ones. Notice that k in the first one is not starting at 1. I want to know the sum of the terms from when k is equal to 3 all the way up to 10. By hand, I would have to plug in 3, and then 4, and then 5, and then 6, all the way up to 10. But with my formula, all I need to do is find the first term when k is 3, the last term when k is 10, and then find out how many terms there are from 3 to 10. Now you may want to look at from 3 to 10 and subtract it and say there's 7. But you're actually using the 3. So there's 8 terms. Count on your fingers with me. 3, 4, 5, 6, 7, 8, 9, 10. I have 8 fingers showing because you're starting with the 3. Okay, when you subtract, you're taking the 3 away. Okay. So to find n, you can do the top number minus the bottom and add 1. It works for the previous one we did. It's intuitive for us to say from 1 to 10, there's 10. But really, if we subtract 10 minus 1, we end up with 9, and we have to add the 1 back in. So you can count on your fingers from the bottom number to the top number. Honestly, that's how I recommend doing it. Or you can subtract them and add 1. Okay, so in this case, my n is 10 minus 3 plus 1, 8. So 8 divided by 2. I'm going to find A1, the first term that I'm adding up, by plugging in the bottom number, which is 3. So 2 times 3 plus 1 is what? 7. So my first term is 7. Then what am I going to plug in to find AN? The number on the top. Plug in the 10. 2 times 10 plus 1 is 21. Eight divided by 2 is 4. 7 plus 21 is 8. 28. 28. And 4 times 28 is 112. So the sigma notation equals 112. Okay. Now try yours.